Oh man, my quarantine haircut is coming back. I look terrible today. Terrible. This face. Oh god, the hair. This face. When we're talking, the face is lovely. The hair is out of control. Anyways, welcome guys. We have a rise and shine homework example problems here. Got some examples, right? These are just examples. These are just some that are going to be on your homework today. Your asynchronous classwork and homework. And what this section is section 3.3, day 1. We're just doing day 1 and 2 here. We're using congruent triangles. And this is a big one, guys. If we're going to use congruent triangles, right? We know one triangle is congruent to another triangle. How could we use those triangles? Well, my guess is where your brain should go to here is that if you're using congruent triangles, like I know that I have this one triangle congruent to another triangle, my guess is that you're going to then use CP, to prove other things, right? Or to get us to prove that two sides are congruent of two corresponding sides of two different triangles, or two angles are congruent, two corresponding angles of two different triangles. And that can help you get to parallel lines, okay? So to prove angles and sides and eventually, right, parallel lines. Okay, so that's what you need to be focused on here. How do you get lines parallel to one another through CPCTC? Well, you need another step on top of that. So you might face all of that stuff here. All right, so just 3 problems today. You got 9 problems on your homework today. I'd recommend spending up to 5 minutes on each problem and just like showing me good work on them. So I do have to see work for each and every one of these because only 9 problems, that should be enough to at least start every problem. So here are all the problems here. Just as a reminder, we have this spreadsheet here, which includes everything we've done, all the definitions, all the postulates, all the theorems that you may have known in a section. So it's helpful to review this every once in a while to remember what we talked about. But most importantly for something like today is to see what all the homework problems are. And that's last week. I'm looking at the wrong thing. This is this week. So you have the classroom exercises number 1 through 3, and the written exercises 1, 3, 5, 7, 8, and 10. That's on Tuesday, November 17th. So let's get into it. Let's do the classroom exercise number 1, and then we're going to do classroom exercise number 3, and then finally classroom exercise number 5. You might be wondering, where's the given and prove statements? Where's the diagram? Well, I need to see that you wrote that out on your sheet of paper, right? Because it's a great way to get started on proof. It's also part of a complete proof. So we're going to do that together in number 5. So just a reminder, any proof, right? Any proof, the fill in the reasons ones, it's fine if you don't draw the diagram, right? That's fine if the fill in the reasons, fill in the blanks here. But if you're going to write a complete proof, that just says, hey, write a proof with these given premises in this diagram. You better copy the diagram. You better write the given and prove statements. I can only say that so many times, right? So many times before I really start expecting you to do it in order to get something approaching full credit. All right, anyways, we got number 1 here, classroom exercise. It says, explain your plan for a proof. Nice. We don't actually have to prove it. We got to show that we would know how the proof would work. Okay, so I don't need to do 2 columns, nothing like that. What I would still do in this one here, it says, given E is the midpoint of segment DF, just robotically, right? You want to find yourself being at the end of this class kind of a human, kind of a robot. If E is the midpoint of DF, well, then that means that those segments are congruent, right? Because a midpoint is the point that creates 2 congruent segments out of the one segment, right, that we have at the beginning here, or something like that. It's worded something like that here. So just programmatically mark those off as congruent. Angle 1's congruent to angle 2. Yoink, yoink. So now I have SA. SA, is it going to be ASA? ASA, right? ASA, or is it going to be SAS? SAS. And let's figure out what else we're given here. We're given CE, so it's going to be SAS here. So we're given that CE is congruent to GE. So if you check it out here, right, what we notice now, we can map it back to what are the 3 potential ways I can prove that triangles are congruent. We got SSS, we got SAS, we got ASA. Definitely not going to be SSS because we don't know anything about that side. Don't know anything about that side yet. So we have this pair of sides, and that pair of sides are congruent. So not going to be SSS. It's not going to be ASA because we don't know anything about angle D and angle F yet. So it's going to be SAS right here. Side, angle, side, right? That side here is included between the 2 sides, right? That angle is created by the 2 sides that we know are congruent to these 2 sides down here. So it's SAS in both triangles. Side, angle, side in both those triangles here. Okay, so this is what I would do here. So in order to plan this proof out is, I would say I can prove the triangles congruent by SAS, and feel free to use these like abbreviations and stuff like that to make your writing a little bit easier here. I can prove the triangles congruent by SAS because I am given CE congruent to GE, and angle 1 congruent to angle 2. Since E is a midpoint of DF, I know DE equals EF. Okay. So the two triangles are congruent by SAS. Okay, is that enough? Is that enough for the proof? What was it looking like? What do we have to prove here? Okay, we're just trying to prove the triangles are congruent. No, we're going to use congruent triangles. So now that I know that this triangle is congruent to this triangle, I can say any of the corresponding parts of the triangles are congruent to one another. So this has got to be congruent to this. And the reason for that would be CPCTC. This triangle congruent to that triangle means this angle would have to be congruent to that angle because they correspond to one another. That I might want to say the exact correspondence here, right? Triangle CDE congruent to triangle GFE, right, by SAS. Okay, so I might include that in there. But that's not the corresponding parts that we're trying to prove are congruent. It looks like it's these ones right here. So check this one out. We got CD. How would I know that CD is congruent to GF? CD, CD is this one over here. This is what I was trying to prove at the beginning. 1, 2, take 3 tick marks, question mark. 1, 2, 3 tick mark. So now we can assert this, right? Sure, they looked pretty darn congruent at the beginning of the problem, but it took us proving that the triangles were congruent because now I know that CE and G. Ooh, wait, GFE, that doesn't make sense. GFE, CDE, oh, GF. Oh, I wrote the congruence wrong earlier. Hold on. Made a mistake. Mr. Fortin, what the heck? CDE corresponds to GFE. Yes, that was, I'm right now. Okay, sorry about that. GFE. Okay, so GFE and CDE corresponds here. So if I had to re-show you this one here, we got CD, GF, right? They correspond right now. So that means that segment got to be congruent to that segment because the darn triangles are congruent to one another. Okay, so that means segment CD, segment GF are congruent by CPCTC. Okay, so could you have written that as a 2-column proof? Sure, you could have written that as a 2-column proof. It might have felt easier to you, but sometimes it's more helpful to talk through it, right? Talk through it. And also to proofs, when you get to college, right? If you study this stuff in college at all, proofs aren't going to be broken down into 2 columns for you. They're going to be written out in paragraphs. You got to be able to follow that reasoning and contribute that reasoning in paragraph form. So we're going to talk a little bit about paragraph proofs a little bit later. It's starting to get you to think about that now as you're getting a lot more practice with proofs. Okay, number 3, not a paragraph proof right now, but it's going to follow the same structure. Think about what we did here. We stated all of our givens. We used some definitions. I didn't mention definition of midpoint here, but definition of midpoint to get some sides congruent. Once we had those 3 parts congruent and we had an SAS correspondence, we would say that the triangles are congruent by SAS. What do you say after triangles congruent? Well, you say CPCTC to get a part congruent, okay? So one of the mistakes that I'm seeing people make here in the early part on the exit ticket is they're saying that triangles are congruent by CPCTC. And that tells me you're not that geometrically awake, my friend, because CPCTC, what does the C stand for at the beginning? It stands for corresponding, and P stands for parts, okay? So CPCTC isn't a reason why you would ever say 2 triangles are congruent, because that's a requirement of CPCTC. CPCTC is corresponding parts, the corresponding parts of congruent triangles. So if you had congruent triangles, then you could say that corresponding parts are congruent. Let's just do an example right now. The big thing I want to show you that a lot of people were messing up on the exit ticket yesterday was that you need to say CPCTC after you've already proven congruent triangles. It's always going to appear after SAS, after SSS, after ASA in a proof, okay? Because those 3 reasons, SSS, SAS, and SASA, those are the things that will establish the 2 triangles of congruence. Then after that, that's how you use congruent triangles, right? Up here, you use congruent triangles. Up here, using congruent triangles. Once you have the triangles congruent, then you say CPCTC to show how you know that the corresponding parts are congruent. Okay, so it looks like we need to get some corresponding parts congruent right here. So I know that this answer here is already going to be CPCTC. You can already put that in there. Okay, right? I already know that's going to be. Look, check it out. I got triangles right here that are congruent. Those are corresponding parts of these congruent triangles. So I got RQ and I got RS right here, and they are certainly corresponding in the same position and named congruency here. So RS congruent RQ because corresponding parts of congruent triangles are congruent. Stay awake. Okay, what does CPCTC mean? Okie dokie. So anyways, we're looking to prove this. Let's maybe start it off from the beginning so you guys can see a complete example. RP bisects angle QRS. We got angle QRS right here. So I'm just going to do yoink. And yoink, we're probably going to use what? Definition of angle bisector at some point, because this here, PR, right, is going to cut this into two congruent angles, right? They're going to be two congruent angles formed out of this whole angle here, QRS. And then we have QPS. Oh, lovely. QPS is also RP. Line RP also bisects QPS. So we have here this and this that we're going to say through definition of angle bisector. So if we look at this proof right now, it looks like the very first step here is going to match up our given premise. Okay, so we're going to exhaust all the givens. That's nice. We won't have another reason that's given. Okay, so we have a given, and then I marked it up already. So we're telling me, so it's not just enough to say that we have a shape that's a bisector of another shape. Again, we're trying to prove triangles are congruent. So we need to say that that helps us either get sides congruent or angles congruent. So what here, having an angle bisector means you're going to have congruent angles created here. So step 2 is going to be definition of angle bisector, my friends, because right, we are having some bisectors being, some angles being bisected. And that's how I know that QRP is congruent to SRP. And how I also know that QPR is by SPR, because that feature right here, PR, is a bisector of both of those angles. Then we have this, my friends. This is a pretty good one here. This is a little bit less geometrically awakened, but still pretty geometrically awakened. That's a reflexive property. Know it, love it, you need to do it. Okay, reflexive property. You might be wondering, why am I just saying that this is congruent to itself? Why am I saying that? Why do I need to do that? Well, how are these triangles going to be congruent? Okay, so here we had an angle. We had a corresponding angle here in this triangle here. We're trying to get to these two triangles being congruent. How am I going to know that they're congruent? Angle here, angle here, angle here, and angle here. So what's going to be the reason why that these are congruent triangles? Okay, the options we have to prove triangles congruent right now is SSS, SAS, and ASA. And if I already know I have a pair of angles, okay, there's an angle here. I'm going to start to check mark the angles. If I have a pair of angles here, it's probably either going to be SAS or ASA. So I'm going to cross SSS off. But I got another pair of angles. Look, I have another pair of angles here. So there's another pair of angles right here in ASA. So my guess is it's not going to be SAS. It's going to be ASA is the reason why this triangle congruent to that triangle. So if we look at this here, we have an angle and an angle here, and they're connected by a side that we know is congruent to itself, because it's a shared side, right? That was a big part of the last video, that video lesson that you guys did yesterday. It's a shared side. If it's a shared side, you're getting a freebie right now, right? You're getting a freebie right now. So if we look at this, we have a pair of angles. We have another pair of angles. And this here, this is the included side. The included side, the side that's included by those two angles. The side that's included by those two angles, meaning that those two angles share a common side, right? They form a side here. Sides RS and RP are the sides of angle PRS. Sides PR and PS are the sides of angle SPR. So what is the shared side they have in common? Well, it's this PR, right? That segment right there is shared between the two. It's on both the sides of those angles here. Okay, so that's the included side. So because of this, the reason why we know the triangles are congruent is by ASA. Okay, ASA. Angle, side, angle. Angle, side, angle. Did you need to say it in that order? I need to get one angle congruent, and then I need to get the side congruent, and then I need to get the other angle congruent. No, you don't need to do that. But in your diagram, right, in your diagram and in your names congruence right here, right, you need to have it corresponds that way. Angle, side, angles. This angle, the side needs to be included. All right, final step here. So I said I would tell you this, guys. What's the final step here right now? What do we need to do? How do we use congruent triangles? So I know, because I told you this at the beginning here, right, that RQ and RS, they correspond. They correspond in that congruency here. So what triangle QRP is congruent to triangle SRP communicates to us is that angle P is congruent to angle P, and angle R is congruent to angle R, and angle S is congruent to angle Q, right? In those triangles, right? Angle Q. And also QR is congruent to SR. RP is congruent to RP, right? We already know that because of the reflexive property. PS is congruent to PQ. And let's look at here, PS congruent to PQ. I'll buy that. So what that is communicating to us is that we can take any of those things and say that any of those pairs there are corresponding parts of congruent triangles, right? And if they're corresponding parts of congruent triangles, then they are congruent to each other, okay? So this is why, and this is a big one, guys, that I was seeing mistakes on this. And just like, I was confused for a month about what CPCTC meant, but this is why you always, okay, you're always going to use CPCTC after you've established the triangles congruent by SSS, SAS, or ASA. Okay, so that was probably the biggest mistake I saw on the exit ticket yesterday was the proof where you need to order the reasons here. A lot of people are saying that the triangles were congruent by CPCTC. That doesn't make any sense. Corresponding parts of congruent triangles are congruent. So if we made that an if-then statement, that would be if you had congruent triangles, then corresponding parts are congruent, okay? So CPCTC doesn't get you congruent triangles. You need to already have congruent triangles, okay? So ASA, SSS, and SAS is the way you get triangles congruent. That's why these are mapped up. CPCTC is what you get for the parts, right? Saying parts are being congruent. The next step and kind of proving things here. All right, final one here, number 5 here. We got this down because reminder, okay? Big reminder. Okay, every proof you write must include a diagram and written out given proof statements. And huge plus on this, shows me actually being thoughtful and thinking about this, is you're going to mark up your diagram, right? Mark up your diagram. Again, huge hint, getting you unstuck. It's all about getting you unstuck, all about getting resourceful. Like, how do you learn from Mr. Fortin's tips? How do you develop your own tips? That's what it's all about, and sort of having it come together. So you got to include, okay, got to include that diagram and got to include your given and prove statements. And you're going to mark up that diagram because that sort of writes the proof for you, right? Writes the proof for you instead. You don't actually spend your time looking at the actual problem right here and getting overwhelmed. You're just writing it down, copying it down, and then you're going to tackle that because you're going to understand what to do here. Okay, so we're going to do number 5 right here. And for this, I'm probably going to draw the diagram. I always draw my diagram out first. You're welcome to start it however you want, but my diagram starts me getting thinking about things that I might end up talking about. And so we have a bunch of angles here. We have some sides, right? This triangle will probably prove congruent to that triangle. So we got to think about how we're going to do that. So let me copy it down. Oops. Let me copy it down. So the top segment is SK. Okay, so that's SK. So let's do it. You can time me. How long is this going to take? SK, KR, triangle SKR. So you're just getting to know the diagram by copying it down. And you're not just like panicking, being like, I can't do this. Because you can do it. You can do it. It's not too bad. Okay. And then this is N. And then we got some numbered angles. So this is 2. This is 1. This is 4. And this is 3. So, right, if we got 1 congruent to, sorry, if we got 2 congruent to 4 and 1 congruent to 3. Oh, and look, this is congruent to itself. That might be necessary. That might be ASA right there. So anyways, I'd maybe start marking up things you could potentially mark up that might be helpful. This is congruent to itself. So I'm probably going to say SR equals XR somewhere in this proof, because if I can get that angle congruent to this angle, that angle congruent to that angle, then we'd have an ASA congruency. Okay, so that might be helpful. The rest is in the given here. So we might want to mark it up so we can see what we need to do here. Okay, so we have SK is parallel. It'll be very hard to read these things. That's part of the reason why copying them down is good to go, because you can just be like, read it. Oh, I'm not doing this. I'm not doing this. I know you. We got that here. SK. Okay, so we have some parallel lines. Very nice. How do parallel lines help us get angles to be congruent to one another, prove angles congruent to one another? Well, I don't know. I'm going to mark that up. Those are parallel. Those are parallel. Interesting. What am I going to, that's not going to tell me. Well, this line, that line parallel to each other. Ooh, SR is a transversal. So this is going to be the trick to getting that angle congruent to that angle. How do I know that? How do I know that angle 1 and angle 3 need to be congruent? Well, these are two parallel lines. So if two parallel lines are cut by a transversal, right? This is the transversal. Then these are interior angles. So they are alternate interior angles. Then alternate interior angles are congruent. Okay, very nice, very nice. Let's do the next one here. The next part is this, SN. SN is parallel to KR. And nice, I think that's going to help us because, right, that parallel to that. I'm going to put 2 tick marks down so we don't confuse them here. And this is nice here too because now these are the parallel lines and this is the transversal. Okay, so that's going to help me get that these alternate interior angles congruent to one another. Okay, so now once we say all this stuff, it looks like here we're going to have an ASA correspondence in terms of those 3 parts all being congruent to one another correspondingly. So that's going to be enough to say that the triangles are congruent. And then ultimately, what do we have to say? Number 5, we have to say that SK is congruent. Our proof statement is SK congruent to NR and SN congruent to KR. Okay, let's check this one out here. We're able to do that through CPCTC. Let me check it out. SK, sure, that's a corresponding side to NR. Yep, the corresponding side of what we're hoped to show congruent triangles. And then SN, yep, another corresponding side congruent to KR. Okay, so now we have an idea of what we're going to need to do to go from here to here. We just need to make it connect, right? It's like you know what your essay is going to say, you know how it's going to kind of get laid up. Now we just need to write it out logically using the rules we know, right? Using the rules we know, just like writing an essay, right? With an essay, you don't just like write down everything that comes to mind. Be like, oh, I know this, I want to say this. There are some rules you got to follow. There's some things that your teachers are trying to teach you to get you to approach it in a logical and valid way that's convincing. Okay, so what's more convincing than writing something out in a very well-organized 2-column proof? Nothing's more convincing than that. That's the nice thing about this class here. Okay, got our statements and got our reasons, and let's go ahead and prove this bugger. We got number 1, SK is parallel to NR, and then here we have SN is parallel to KR. So now that the hard part was done, which was just kind of like looking at things, now we just need to get it written, which is kind of nice. You take a deep breath, kind of do it. Okay, so we had parallel lines first. I jumped to getting the SR thing just to keep myself organized. I'm going to say SR equals SR, and that's by reflexive. Okay, that was important because that gets me to sides are congruent. And now I just need to get the angles. So you're staying organized and making sure you're including everything in there that you talked about before to make this be a logical form of flow of this. Given premise, what are the things I need to say, right? So we got to actually say them. I know you know them by looking at it, breaking it down. Now you got to say them. How can I go from this to get us to there logically? Okay, so I want to say those are the sides, and now I got to get my angles. So I'm allowed to say, because I had these lines, this pair of lines parallel, that pair of lines are parallel. As a consequence to that, I will know that angle 1 is congruent to angle 3, and I will know that angle 4 is congruent to angle 2, because again, I know that SK is parallel to NR, and these are alternate interior angles, 1 and 3, so 1 and 3 must be congruent. And I also know from my given premise and what I listed in step 1 that SN and KR are parallel, so therefore I know that angle 2 and angle 4 are congruent because they are alternate interior angles. So break it down. What's my justification for that? Well, it's this theorem that we learned in chapter 2. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. Okay, and then let's keep jumping through it here. All right, so now we have the sides, and then we have the angles that include. So we got a couple angles, we got a couple more angles, and you don't have to write the sides, angles down, but it could help you stay organized to remind yourself that you have an ASA A correspondence. A, S, A correspondence. Okay, so let's do it now. Let's say that the triangles are congruent. So we're going to do triangle. And here's where I'd look. 1 and 3 correspond here. So 1 and 3. So that means triangle S, I'll put the congruency symbol there. It's going to correspond. So if 1 and 3, right? This is the angle S and SKR, I guess. S is angle 1. And then 3, it goes with R is the vertex here. So I'm going to do S goes to R in this triangle. Then I'll maybe go to N here. So we got S, K, and K and N correspond. So I got triangle SKR is congruent to triangle RNS. Kind of be kind of hard to spot the correct congruency there. And that is a big thing. It's definitely something that we check for, right? To make sure that you're communicating what are the congruent triangles and how we can figure out what the corresponding parts are of those congruent triangles. Okay, so one way to check this a little bit here, SR corresponds because we have RS right there. It's all good. Yeah, K and N is the best thing. Those are both in the middle. And yeah, this one I think is good to go. Reason for this one is, well, we'd said angles, and then its included side is ASA. Step 5 is how we're going to wrap this one up, I think, because step 5 was just this. Corresponding parts of congruent triangles are congruent. We got these things, right? These guys, this is here, okay? These are corresponding parts because corresponding parts of a triangle are angles and sides that correspond. Here we just have some sides we need to get to correspond. So these are corresponding parts of congruent triangles SKR and RNS. Okay, these are corresponding parts of congruent triangles, right? Those two triangles are in there. Therefore, what? We know that they're congruent to each other. C, P, C, T, C. That last C there says that those corresponding parts are congruent, and that's exactly what we need to assert here in our final step. So we got SK is congruent to NR, segment NR, and we also have that SN is congruent to KR. And that, my friends, is how we're going to end the morning. We're going to stay super CPC. Whoa, Mr. Foreign's not awoke yet here. He's not awake. CPCTC. Drop the pencil. We're done here, folks. Email me if you have any questions. Those are 3 of your 9 problems. So hopefully that gets the ball rolling if you were having trouble getting the ball rolling this morning. I'm seeing many of you guys for office hours today. If you need some extra help on the exit ticket, please come by to office hours. But good work from a lot of folks in the exit ticket. It was really nice to see those. And man, we're in the thick of things. It's good stuff. We're going to let the ball roll. This is just like it. We got through all the painful first 2 chapters. And let's just let the ball, it's going to be painful every once in a while. But we gotten far enough where we can let the ball roll kind of the rest of the year and get through all this stuff and be together and hang out and be good times. Have a great Tuesday. I will see you guys tomorrow on Wednesday. Bye-bye.